computers.
It's me against you, Eric.
Okay, fire them up.
Alright, so, first thing, kickoff, you gotta know the game. You gotta get people on all the paperwork, understanding what the little nuances of the game are right away. Okay, you gotta go through your kit of parts. You have to know what you are given and what you can buy. So that's part of also knowing the game, but knowing what's inside of your box and what you're gonna have to purchase are two different things. How much money do you have? I mean, it'd be great if we all had, tons and tons of money, but the fact of the matter isn't, that most of us don't have tons and tons of money, and we have to start prioritizing ideas. So knowing your budget, knowing how far you can go, how crazy you can go, is important. Setting up some sort of time management so that you're not just flailing about, so that you have teams working on specific tasks and you can track them, that be done on specific dates, and that you can follow up on these things. And know your role in the team, so you're going to have different teams. They're divided up. They're going to perform those specific tasks and also be followed up on and be responsible for those tasks. Not having a clear-cut requirement of what you need to do means a lot of people milling about, not doing anything. And that's frustrating for the people milling about because they really want to do something. So give them something that's productive to do. I mean, running the track or pushing a wheel down the hallway doesn't quite count for that. Work with other teams. There has to be inter-team communication. You've been making the gripper and the other person's making an arm, or if they don't connect together, or the gripper's too heavy for the arm, these are problems that you have to work on. Agreement on some sort of design concept, some sort of overall design concept. There's still room for flexibility for a certain amount of time, but you need to have some sort of clear path that you need to follow towards your goal, and that usually boils down to the design. Know what your team can do. If you have a small programming team that can only program in a specific language, and then you throw some weird concepts at them that they can't work into it, your robot would run if you had a team that could build it, or a team that could program it. So understand what your team is capable of. A lot of this happened preseason, but you have to kind of distill that for the actual post-kickoff event. What we can do, what we can't do. Do we need any additional parts? Is there anything we can look at this kit of parts, look at what we have in our supply house and say, okay, to do this, we definitely need X, Y, and Z. Go get it now, because it takes time for these things to show up at your school. Okay, so order early and a lot. Then there's always the build it part. Building the robot's also important for the competition, so make sure you get that in there. Then we have to test the robot, and then we have to edit the robot, and then we have to wash, rinse, repeat. So we have to go back and build, test, edit, build, test, edit, build, test, edit, build, test, edit, and hopefully you have time to do that repeatedly. Bag and tag it. We weren't really running on a specific list. Those things kind of happen in order. Then we started thinking what else we missed. We need to make sure we review the rules and requirements. You need to do this often so that you don't get stuck in some sort of path that's going to mess you up down the line. Working up transportation, hotels, food, things if you have to travel to the event, you need to make sure that's taken care of because hotels fill up quickly, and which means that you have to book further away, which means you have to book in between transportation. So these things can mount upon themselves if you don't do it up front. So as soon as you can, get your bookings done, get your bus rented, or however you get from point A to point B, make that happen. Location, where are you going to build the robot? How are you going to feed the robot? They get hungry. Not the robot. The students, if you're working 8-hour shifts, you have to put food in them. You probably, if any of you have kids, you know that they get cranky when they don't eat. And we don't need 40 cranky kids with hammers. It's bad. When you go to competition, you need to make sure you have tools and replacement parts. Not just replacement parts for what's on your robot. This is a collective team competition, and people will come up on the PA and say, we're looking for an 1/8-inch spanner wrench. Does anybody have an 1/8-inch spanner wrench? And you, as your cooperation type person, you need to get out there and you need to see, if you have that, you need to make it available. Okay, not only equipment, but bodies. If you have somebody who knows how to program, a team's had a problem with programming, if you have a person who's good with drivetrain, every year we have at least one person on our team who spends the majority of the event in somebody else's pit, okay? Because we want to, okay? They could serve us, but we want to help other people. So it's not assigned, it just happens. It's a very natural thing, and you'll see the camaraderie going on in the events, that these things just, they naturally propagate out. Your sponsorship, this is important because if you're making t-shirts or banners or anything big, or if you promised your sponsors that you'd get them noticed, that you need to make sure that those things happen. Okay, sponsors' names on the robot, sponsors' names on the banner, sponsors' names on the shirt, sponsors' names on your forehead, whatever you promised your sponsors, you need to do. And swag, this is the game show version of swag, not any of the other versions of swag that you might be hearing about nowadays or from other things. These are the little the things you give away to get your team some recognition, some notarization. A couple things are the silicone wristbands, buttons. Those are two big things we did. Last year we did Rubik's Cubes, which were a bit much. But people like to trade. You know, buttons, pins, beads are another big thing, lighted necklaces. It helps to get students talking to each other. Okay, so, oh man, it's a great button. Where'd you get that from? I got it from Team 492 over there, man. Let's go talk to them. And then, you know, you all go together and you chat with people. So it helps with the camaraderie and the cooperation concepts. So make sure you have something to give away, even if it's just a business card with your name on it. Something simple as that, where people can find you. You know, you might end up being one of the top people that they're looking for because your robot is just so awesome, and they can look at that card and say, hey, I have all their information right here, so I can contact them next year, or even find them in the pit somewhere, so that they can communicate with you. So something in hand that has your name or your number on it, preferably both, that you can play with. That's all I have.
That was fantastic. Wait a minute. You think it was fantastic? I'm going to speak for the rest of it. I'm going to give a standing ovation.
Sorry, Eric. I don't know if I see it better.
And your team number is 2890?
Yeah, that's these two.
2890. Oh, you're 2890 also?
Yeah.
I think it has
And
the
those
first
two.
First button.
These guys, these guys.
That make you go.
Awesome team.
Okay. You're Eric?
Yes, I'm Eric.
2890.
I'm on Team 2890 with Mr. Slater and these Adam and Sam here. Basically, Mr. Slater said our basic plan, but another way to go, and particularly the build season, is you have to know the game, how it works, and also you need to know your plans, what you're going to do, what each person's going to do, and how it's going to be done. Another thing is you have to understand the rules, because if you don't understand the rules, you might be over 20 pounds overweight, or it's too big, or your arm might just happen if there's a programming mishap. The arm might move out of its box when it's not supposed to. And then also you have to make a plan, set goals, weekly goals, maybe even daily goals, so that you know your team is on the right track, so that you're building a robot, you want to finish the chassis by first week or second week, you want dates. Another thing is to design the robot. Design it on paper, 3D Studio Max, CAD, anything. You gotta start making designs for a robot as soon as possible. And then with those designs, you have to start using a process of elimination to then make a prototype, whatever, scale it down if you want, to save materials, same size. You have to then test that constantly. You want to try to find every flaw possible in it, and then make any adjustments that you want. And then after that, after you make the final adjustments, you then want to take that prototype and then get the materials that you used in that, get more of it so you can then scale it up if it's not the same size, anything to make sure that you have it. That's where normally a lot of money has to come into hand, or sponsors, and you want to make sure that you have someone that's able to do that for you as the majority of the team has to focus on the robot or programming it. Another thing is after that, it's just basically setting a schedule, same thing as the planning. It wasn't in particular order, but once you do the testing, the prototype, getting the final adjustments, you want to start building the actual robot. You want to have most of the build season time of that 6 weeks to be building that robot, because that's just, it's a pain. And then once it's done, you want to at least have as much time as possible to sit there and test it, practice, because going to a competition with no practice is not an easy thing to do and win. And that's basically it, other than what Mr. Slater has said about making sure if you did get sponsors that you do hold your end of the bargain.
Good. That's good thinking. You didn't even have a hat on. You didn't have your thinking cap on. Yeah, and again, we'll get into slightly more detail, especially, remember, we're talking about the getting started specifically, and what I'm talking about here is that first week in particular. But these are excellent, excellent thoughts. I'll ask kind of a question again back to Team 71, Team Hammond. I want to tell you again is that not only are they legendary in the field, coming from a very, very poor community, former steel community, Hammond, Indiana, up near Lake Michigan, but they didn't have the benefit that us Silver Spoon people had with General Motors when we started the team. They had nothing. They had one sponsor who was a small tool shop that had about 6 employees, okay? And in spite of that, year after year, they would come and set the pace for how to play the game and come out on top of the game. And the lesson learned about that, and those of you who are new to the game, you'll find teams that have outstanding sponsorship. And so from a monetary point of view, they have all that you could ever want and then some. Especially in my GM career, we had teams for the GM Milford Proving Ground, the Hot Lots, which is Team 67, I think it is, okay. Infinite resources. We had the GM truck team. They would come to the competition with a truck. They had a dedicated truck to come to the competitions with, okay. Infinite resource, okay. Now they would do reasonably well in the competition, but Team Hammond would still beat them. And the lesson I'm trying to get around to here is the most important thing of all, which is about what creation here is about, is thinking not that you got $1 million at your disposal. And they are the classic example that the ultimate power here is not who's got the most resources, it's who's got the best thinking, okay, and turning that thinking into something. That's the innovation process. So, yes, it's great to have great resources, it's great to have a lot of sponsorship, and in fact, it's essential. I mean, you can't make a silk purse out of a sow's ear, as they say, so to speak, to some extent. Okay, maybe you can relate to this, but most important of all is the thinking, okay, the cleverness, the innovativeness, and Team Hammond exemplified that year after year. They had nothing in resource. Now, in addition though, what they did get was their passion for what they did. I mean, year round, they were on it, okay? Year round, they'd take their robot out, put it in the parade going down the street, have bake sales, have cookie sales, have donut sales. I mean, everywhere you turn in Hammond, Indiana, they were a force, okay? And they just made it happen. But they didn't have GM truck behind them, okay? They had this little half a dozen tool shop behind them that could barely make it in Hammond, Indiana, because the steel industry's dead. Okay, so getting on to slide 3, or slide 2 actually. And again, nothing really new here, except to expand on first couple of these items here near the very beginning, okay? As you've said here, there's repeats here. We'll go down here real quickly again. Get the game challenge, get a strategy, we agree on how we're going to play the game, sketch concepts for the overall robot design. The team selects an overall layout, an overall robot configuration. Create an overall layout, by whatever means. Most teams can use computer-aided graphics these days. Define subsystems and subsystem design teams. Imagine, sketch subsystem design concepts. Prototype those subsystem designs. Select a subsystem. Buy, design, freeze, make detailed drawings, fabricate the components, assemble, test, debug, select a drive team, pit team, and scouting team, practice, ship the robot, compete and win. Now, up here near the front is where I wanna really emphasize again, because if we don't get started right, we can do all these other things later real well, but we got to really, really bore in on the game challenge and the game strategy. And this, and also, we need to understand up front that we're gonna be on a time schedule here, and we're gonna make a chart that lays out, because we only got 6 weeks. So on these mileposts here, we gotta know where we gotta be on those mileposts to that 6 weeks. We gotta have it understood. The team needs to be all working in cadence to that. And we have to have what's called, in the engineering business, we have to have what's called design freeze. And as a 40-year car guy veteran, okay, let me assure you that the toughest thing, and they don't do it well on General Motors, I can tell you that, because we'd have PERT charts and time charts that say, okay, we gotta be here, gotta be here, gotta be here, and then we get to this point and we aren't there yet, okay? So what do? Make a new chart, right? Okay. No, at first, you don't make a new chart, okay? This time, right here, the end point is fixed. It doesn't move. And if you don't get there, by the time it's there, you don't play, right? For you people who have experienced this before. So there's no give on where this end point is. So therefore, you need a time chart, and it has to be adhered to, and especially design freeze. Back here where you're prototyping and imagining things, you know, and somebody says, I think this is the way we should do it, and somebody says, I think this is the way we should do it, and a third person, and then Johnny come lately comes here and says, I think this would be the way to do it, and maybe it is, okay, but it's too late, okay, because there has to be, and that time has to be somewhere around the, at the latest, it's gotta be around the halfway point, okay, where these subsystem designs, whatever they may be in the prototypes, they have to be chosen by the team, and they have to be executed. You know, time runs out, you have to freeze it. Wherever you are, this is what we're gonna do, come heck or high water, okay? This is discipline, and in fact, one of the beauties of this process is it is fixed at the end from a timing point of view with no give, okay? So when you make your time chart, you gotta say, as we move down the road here, where's the design freeze point gonna be? Now in our case also, every day, we would work on it every day after school. This was an after school thing. And every day we'd have a show and tell session, okay? So every day, especially after we worked into the subsystem design teams, okay, there's maybe a chassis team and a manipulator team and a programming team. You know, you break this job down into the subsystems. And now every day, each of those teams would show and tell where they were in the process, which not only showed them and ourselves as to whether they're staying on the road, but also kind of indicated that, gave us a clue of how the whole thing was coming together, okay? Because in the end, it all has to come together. Now, I think it was the lady in the green sweater back here, your name is?
Oh, Stephanie O'Brien.
Stephanie?
Yeah.
I happen to be listening in here, and I think you had hit upon what in the earliest days, I believe is the most important thing. More than this generic develop game strategy, which is clearly true, but how do you do that, okay? How do you do that? In the case of whatever the game or the challenge may be, there's gonna be some kind of a point power system, okay? Some functions that are part of the game are gonna be harder to do than other functions, and so whoever is designing the game is classically going to say, well, in a pointing system, that's going to be worth more points than something else. So the trade-off is that obviously, you know, you're gonna be trying to maximize points, no matter what the game is. And you're certainly gonna want to do that, maybe by doing the most difficult things, which have the most point power to them. But what's the trade-off there?
Complexity, probably.
Yeah, they're harder to do, so conceivably, you could set out to have your robot just do the high point things, but the complexity's there, and it's conceivable that in the 6-week time period, you might find out that you never get there, okay, because it was too complex for you, okay? So there's a risk return type of thing here, which is part of the engineering process always, okay? That's the learning experience here. I'd like to have all the 5 pointers I can get, but, and I don't like the 1 pointers so well, okay? Because it takes a lot more of them, it takes 5 for every one, but the 1 pointers are dirt simple for my robot design to get to, and the 5 pointers are a lot harder to execute and get to, and maybe so hard that I could work 6 weeks and never get there, and that'd be a real bummer. So in this give and take kind of thing, an element that has to happen here in game strategy is, and what we would typically do, and I've got a slide that details this, we, on day 1, after the game's rolled out, and you start to understand the game, know the game, we would basically break our team up into about 2 or 3 groups after they'd had time to sleep on it for a day or 2. And thinking about the scoring matrix that was associated with that game, and get them to at least make estimates of what kind of score would be necessary to achieve in that game in order to win most all the time. Not all the time. I mean, that's easy, you know, make some spaced out kind of an estimate, say, if we got 100 points every game, we'd always win, okay? No, again, it's a judgmental thing. And so we break the teams into 3 or 4 groups. We give them a little bit of time after they've studied the game a while, and each of them would come back with their idea about how many points it would take. Let's just say, to estimate it, how many points is it going to take with this game to win 75% of the time? You know, over half, 3/4 of the time. Not all the time, but most all the time. How many do you guess? Now, I mean, this is really a judgmental thing, to be sure, because you never played the game before, and actually nobody on earth quite knows that about the game. But you make a guess, okay? And you come back with those several estimates, and oddly enough, for the most part, if you get 3 groups together and give them a while after having contemplated the game, you'll find out that their estimates for how many points it takes to win most of the time aren't that far off from one another. So you take all those and you kind of say, okay, for right now, we're going to say, given all those judgments, that we're going to try and achieve at least, let's just say, depending on the game, we're going to build a product that's going to get at least 50 points. And then that begs the question, in what ways can we get 50 points? Okay, which gets to your comment, which is so prescient, okay, about not only the strategy, but starting out with how are we going to win most of the time? What's it going to take to win most of the time? And by the way, not with our partner. Typically you'll have a partner or 2 as the games roll out. I've never seen a game where it wasn't at least playing in pairs, okay? But this is about how are we going to get that number of points by ourselves, partner or not, okay? And this was key to the Team Hammond people too. What they did, they never thought about their partners, okay? That gets you off the track, okay? They only thought about, well, what are we going to do in order to get to this level? Okay, by ourselves. Now, if we happen to be with a partner that's really strong and good, all the better. But we don't worry about that. We don't hypothesize about that. we simply set out to provide a product that's gonna get to this level of points on its own most all the time. And then, of course, then you start from that. The next step is you go down and you say, okay, what are the functions, the scoring functions, that are in this game that are going to be the things that we're going to do that are going to get us to that score on our own, which in turn starts to define the functions that your robot has to achieve, right? And again, back to your comment here, this is so critically important because this is all going on in the first day or two after you know what the game is, okay? And it ultimately says for the team to converge, and this is the other key thing. This is a team kind of thing, So what you need to do in those first 2 or 3 days as we move down there is let's say our robot is going to get this kind of points because we guessed as a team that that's what it's going to take to win most of the time. And then our robot is therefore going to achieve that by doing this, this, and this, but not doing everything necessarily. Because that's another key thing that happens. The teams don't converge on what it will do and what it won't do. They're not solid on that. And by not being solid on that, they try and make it do everything, in which case they end up being mediocre at most everything, okay? So what's the points we gotta get? What are the functions our robot's gonna do in order to get that? And the team needs to actually converge on that. That needs to be written down and posted on the wall as the rules. And it's not that those rules cannot change, ever, but just like in Congress, you got laws in Congress, and until a procedure goes on in Congress that actually physically changes the law is the law. And so this is what goes on the wall. We as a team have consensus on that this is what the points we're going to get, and we have consensus on this is the way we're going to get them, okay? Which now sets the stage for designing the robot functions to achieve those things, okay? And again, if somebody along the way, a week or two into this, or there's conversation amongst people and say, gee, I don't think that's the way to get this done. The way you change that on the wall is the leader of the team, typically a student, would convene everybody and you would formally have a discussion. It says, are we going to change the rule and change the chart, or are we not? Okay? And that is a yes or no. And so the rule can be changed into it, but it doesn't get changed without formality. Until it's formally changed, that's what the team is doing. And this creates a convergence, which is, let me assure you, if you've not done this before, is extremely difficult to attain, okay, and keep. But the students need to understand up front, okay, that that's what we're going to achieve in the first 2 or 3 or 4 days. And we're going to be able to put on the wall what it is that this product is going to do. And that we will change that, but there will be a change process. And otherwise, just drive on, because that's what the robot's going to do. Being fuzzy about that is extremely detrimental, because the clock's ticking, okay? So, any comments about that? This is what Team Hammond would do. This is what we learned to do, tough as it is. And people, when they say that they agree with the plan, they need to understand that they really need to mean it, okay? When the team says, we really are in agreement with this, it's not just, they gotta understand that they need to mean what they say here, okay? Because it's not something that you should be wishy-washy about. you either feel it's the right thing and you say, I think it's the right thing, or even if you aren't fully convinced, you need, in a consensus point of view, consensus doesn't mean 100%. It means that at least if you aren't 100% with it, you're not gonna do anything to be detrimental to moving forward that way. I see you, I see you smiling, okay? So, that's getting started. And design freeze and segmenting out the tasks. But again, before you get to what the tasks are, you gotta get here through this game strategy, which again is how many points we gotta get and how we gonna get them. And that happens again right up front, getting started here. That's how we're gonna play this game. And then you can go on to sketching concepts of the overall design. And of course, that's the big picture. Sort of like in a car, that's what you're doing. You know, the car, the whole car is put clay and all that kind of stuff first. And then a car is broken into 19 subsystems, okay? Or 19 systems, I think so. And you know, then you begin to work out the subsystems and the subsystem design teams. And the overall layout then is going on the computer these days, hopefully with some kind of 3D animated capability. Is that typical these days, I guess? So that you can put this thing together, and when things are gonna move, you can make it move so they don't crash into one another and things like that, okay? And that's difficult for the students to get to either. Also, they just wanna get in there and start doing something. And I can understand that, but they need to also understand that before I start making prototype in a large degree, I need to understand something about the size constraints. I need to understand something about movement. I understand, and so on. And so, again, discipline down the deck here. And then when you do prototype, and I was also a chief engineer in charge of our future products for a division for some period of time, global future products. And my expertise is in the innovation process, okay? That is how to innovate on purpose rather than by chance. And what I'm getting to there is that we went out and we found the world's most innovative organization, documentably. And it turns out to be a company called IDEO Product Development in Palo Alto, California. They don't make things, companies come to them and they do the original concepting, the imagination, and the prototyping, and get things to the point of having something to produce, and then they're gonna get produced. What we learned from them, when we talk about prototyping, is you use chewing gum, baling wire, cardboard, easy to work with material, okay? Wood, okay, not metal. And when you prototype, you make the most crude prototype you can, which in turn, once you look at it and you can touch it and feel it, then immediately that sets the stage. There's something about being able to look at something, no matter how crude it is, and it sets the stage for being able to go on and make prototype number 2 or iteration number 2, okay? But it's gotta be quick, quick, quick. Now an IDEO would go out to them, I mean quick, as soon as we laid out the idea, we'd be in a room that afternoon prototyping, okay? And probably by a day later, we'd have 3 or 4 iterations of the prototype done. It's quick, 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 quick and dirty, okay? Same way with this. When the students are prototyping, they don't need to be sophisticated. They just need to turn an idea into something tangible that you can start to look at, okay? No matter how crude it is. Baling wire on a chewing gum. So again, the objectives of a winning strategy is create a robot that can win without any help of any alliance robot. Create a robot that can develop a commanding lead in doing that in the first 30 or 40 seconds of the game. Okay? Not only do you win on your own, but you think about how you can get out in front with a commanding lead. Typically the game is 2 minutes or 2.5 minutes long, okay, so it's like that, it's quick as a bunny anyway. But you think also, we're not only just gonna get the points, we're gonna see how we can get them right out of the chute, okay? Get a commanding lead right away. And again, ensure common understanding by all team members. List all the ways that you can score. That's, how we're gonna get the points. All the ways that you can score. List all possible scoring actions. The team estimates how many points it will take to win most matches. The team agrees on this, and I mean agrees. Prioritize the scoring actions for point power, okay? So if we aren't gonna do them all, we gotta say, well, first and foremost, our priority is this robot's gonna do this, and it's gonna do it good, okay? Second and third, okay, prioritize it. Determine which scoring actions will be implemented to reach the winning point value. These scoring actions will be the scoring actions that your team implements. Do not, if you would, make the mistake of trying to make your bot do everything. Because you'll find that in most cases that means that you're mediocre at everything instead of good at a few things. Reliable also, be good. Write down and post how we'll play the game. Imagine and sketch the concepts for performing each prioritized scoring action and create those, turn those ideas into a winning robot. Here's an example I've got here of a game actually from 2004 that illustrates what I'm trying to say about how we're going to play the game. And this was in fact developed and written down and posted on the wall in 2004 in a game called Triple Threat. Okay, and we determined that we got to score 55 or 65 points on our own to win most matches. And the point power of this game, it was kind of a tic-tac-toe kind of thing is what it was, with some game pieces. And the point power of this was in owning rows of the game in a tic-tac-toe thing. That's where the power of the points were. And we're going to develop a commanding lead in the first 30 seconds by having an unsurpassed ability to manipulate these Tetra game pieces. So manipulation was key, in our opinion, to that particular game and developing that commanding lead. And so what are the features? We got to be fast and easy to operate. We got to grab, lift, and let go easily. We got to self-align and make the Tetra placement easy. We got to place Tetra top up onto the goal. We got to disengage hanging Tetras. So these are action items. These are verbs here. Fast, easy, grab, lift, align, disengage. Okay. Things that we could do. These are musts. These are we could maybe this, and this. We need to be simple, lightweight, and durable. 15-second autonomous period. Normally these days we have an autonomous period where the robot's on remote control, no operator interaction. So what we were going to do right out of the box is cap the center goal here and acquire Tetras, defend own goals, return to the end zone at the end, and 55 to 65 points will almost always win. So there's a specific illustration of what you write down and to implement this getting started, right? And having alignment of the team to go after how we're going to get those points. So again, in summary, an experience here, creating a winning robot requires a combination of a great strategic plan based on point power and a careful determination of what we're going to have the robot do in order to achieve a score that will win most of the time. And a great, reliable, and durable robot. Obviously, durability, and some games are rougher than others. Durability is always important. A great drive. Now, we need a great product, the robot itself, but equally important is a great drive team, a great pit team, and great scouting teams. Okay. A lot of times people overlook the role of the scouts, the importance of the scouts, and the importance of the pit, which is obviously you can understand that it's important, of course, to have the product and then somebody's gotta drive the product, so that's the drive team, so those usually come to mind. Not necessarily, or do you understand that the pit team and the scouting teams are also of equal importance at least. And then what you're gonna need here is not only a great drive team, pit team, and scouting team, and a great product, but you're gonna have to have a lot of luck. Because the way these things work, and those who've been the ones to them, you go to a regional, there's gonna be a day and a half of qualifying matches, and in that case, you're gonna be matched up randomly with alliance partners, and that can cause a lot of variability in what happens to you in a given match. So there's a luck of the draw kind of thing. After a day and a half, let's say here at VCU, there'll typically be 64 teams. 64 teams will start off, and they'll typically get 8 or 9 chances during the day and a half to play. And at the end of that, all those 64 teams will be ranked up based on their 8 or 9 matches and what happened in them. Of course, some of the really good teams, like that Triple Helix team here, for example, you know, the really good teams, and I know that there's been some heartbreak about that in the past with the Triple Helix, because they'd end up ranked maybe in the top 15 or so and wouldn't get chosen to play in the finals and the semifinals. That happened 2 years ago, I think it was, okay?
Before my time.
Oh, was?
Yeah.
Okay. Well, Matt, your lead mentor will never forget that, okay? So at the end of that day and a half, for people who are rookies, those 64 teams will be ranked 1 to 64 in terms of their match results, okay? And the first 8 of those teams now get to choose who they're gonna play with in the afternoon on Saturday, okay? So it's no longer random after that. It's now you get to pick, and teams 1 through 8 are in a picking position to pick their partners from the rest of the 64, and then of course that sets the alliances up for the quarterfinals, semifinals, and finals in the afternoon on Saturday, okay? And as I say, because of the random pairing nature that comes up during the qualifying matches, sometimes a team that's very capable ends up 35 in the rankings, okay? Simply because for a lot of reasons, but because maybe they were unfortunate enough to get paired up with some less than stellar alliance partners. I see you can understand what I'm talking about, right? Okay, but that doesn't matter, because there are, you know, a lot of times the scouting teams, for the teams in the top 8, will, of course, if they've done their scouting right, they'll be able to recognize quality, okay, no matter where the team ranks, okay? They'll be able to recognize a quality team that could be useful to them as part of their alliance.